Hi, in today's video I would like to share with you a very nice problem of Bulgarian mathematical Olympiad. Here is the following information. Find all positive integers x and y. Here is the following equation. We have 7 to the x minus 3 times is multiplied by 2 to the y equal to 1. Okay, so the hint that I'm trying to give to this problem, just try the abuse cases first, then try to factor out these two terms and make it two-side equation in order to make the comparison. Okay, and then transfer this one into the congruence. Now let's jump into the solution. So we have the following equation: 7 to the x minus 3 times is multiplied by 2 to the y equals 1. Okay, I'm going to try first when x equal to 1 and y equal to 1. I'm going to replace 1 with its value. I'll get 7 minus 3 is multiplied by 2 to the y. This one is giving us 7 minus 6. 7 minus 6 equal to 1, which is verifying this equation. Okay, we have the first solution. We have x equal to 1 and y equal to 1. Let's check second solution when we have x equal to 2 and y equal to 4. Because y equal to 3 is not the solution of this equation. So 7 to the 2 minus 3 times is multiplied by 2 to the 4. This one is giving us 49. 2 to the 4 is 16. 16 is multiplied by 3 is 48. So 49 minus 48 is 1, which is verifying this equation. Okay, so here is the second solution. We have x equal to 2 and y equal to 4. Now we are going to see the general case when we have x strictly superior than 2 and y strictly superior than 4. Okay, we'll get 7 to the x minus 3 is multiplied by 2 is multiplied by 2 to the y minus 1. I'm pulling out one of the two and make it as a factor. Okay, equals 1 equals 7 minus 6. Okay, I'm bringing this 7 to the left hand side of this equation and bring back this term to the right hand side of this equation. So this one equivalent, we'll get 7 to the x minus 7 equals 3 is multiplied by 2 is 6 is multiplied by 2 to the y minus 1 minus 6. Okay, now I'm taking 7 as a common factor on the left hand side of this equation and take 6 as a common factor on the right hand side of this equation. So I will get 7 is multiplied by 7 to the x minus 1 equals 6 is multiplied by 2 to the y minus 1 minus 1. Okay, I'm going to call the left hand side of this equation as a red star and call the right hand side of this equation as a purple star. Okay, this is left hand side of the equation, this is a right hand side. If you take a look carefully at both sides of this equation, we have the left hand side of this equation is a multiple of 7. Is also the right hand side of this equation is a multiple of 7 because we have equality. Okay, but 7 is not multiple of 6. Okay, that's mean 2 to the y minus 1 is a multiple of 7. Okay, let's write down that I have 2 to the y minus 1 is a multiple of 7. I'm going to use the congruence definition here. So this is that's mean 2 to the y minus 1 is a congruent to 1 mod 7. Okay, this is congruent definition. So in the other words, now I'm going to work on order. Now I'm going to use this tool, okay, to find the exponent y minus 1. As we know, the exponent of an integer, so the exponent is always a multiple of order. Okay, so now what does mean? Also, I'm going to work on the other side. I have 2 to the 1 is a congruent to 2 mod 7. Okay, because if you take these 2 to the left hand side of this equation, you get 0 here. That's mean 7 divides 0. Okay, what I'm going to do now, I'm going to multiply both sides by 2. I will get 2 to the 2 is a congruent to 4 mod 7. Okay, if you multiply both sides by 2, I will get 2 to the 3. On the right hand side of this equation, I get 8. That's 8 mod 7. That's mean I have one number more than 7. That's mean 1 mod 7. Okay, this implies 2 to the 3 is a congruent to 1 mod 7. Both statements are written on the same form. Okay, so this implies I have y minus 1. Since the exponent is a multiple of the order, that's mean y minus 1 equals 3m. What is the m? Is a sum natural numbers. Okay, I'm going to plug this y minus 1 with 3m and continue with our calculation. Okay, I'm going to bring this one at the top and continue with our calculation. In the last part, we were working on this equation and came up with this result. So we found 2 to the 3m is a congruent to 1 mod 7 by replacing y minus 1 with 3m in this equation. I will get 6 is multiplied by 2 to the 3m minus 1. I'm going to factor out this one. I will get 6 is multiplied by 2 to the 3 minus 1 is multiplied by 2 to the 3m minus 1 plus 2 to the 3 is multiplied by m minus 2, and so on and so forth until you get 2 to the 3 plus 1. Okay, it's very tricky to factor out this one. Just check it carefully. Okay, so now if you take a look at this number 2 to the 3 minus 1 is 7. Okay, so I'm going to put here this one equals 6 is multiplied by 7 is multiplied by this box. What I mean with this box, I mean this number. Okay, this is the solution of the right hand side of this equation. Okay, this one is expressed as a solution of the right hand side of this equation. That's mean the right hand side of this equation is a multiple of 6. Okay, that's mean the left hand side of this equation is a multiple of 6 as well, because we have equality. Okay, but 7 is not multiple of 6. That's mean this term 7 to the x minus 1 is a multiple of 6. Okay, so let's write down that. That's mean the left hand side of this equation is a multiple of 6. Is a multiple of 6. Okay, this one is a multiple of 6. I'm going to transfer this one into the congruence. This one, by using the congruence, I will have 7 to the x minus 1 is a congruence to 1 mod 6. Okay, I have the following equation. Now I'm going to find x minus 1 as an exponent. As we know, the exponent is always a multiple of order. Okay, so it's very simple, this one, to find the order of this one, because we have 7 is a congruent to 1 mod 6. If you take in number 1 to the left hand side, we get 6 here. That means 6 divides 6. Okay, so the order of this one is 1, but using the order rule, so we have the x minus 1 equals k. What is a k? Is a sum natural numbers. Okay, I'm going to replace x minus 1 with k here in this equation. I will get 7 is multiplied by 7 to the k minus 1. I'm going to factor out this one. I will get 7 is multiplied by 7 minus 1 is multiplied by 7 to the k minus 1 plus 7 to the k minus 2, and so on and so forth until you get 7 to the 1 plus 7 to the 0. Okay, which is 1. So this term, this term equals 6. Okay, that's mean this whole expression equals 6 is multiplied by 7 is multiplied by this box. What I mean with this box, I mean this expression, this term. Okay, if you take a look, both expressions ends with the same values. Okay, so both values 7 and 6 shows in both expressions. That's mean we are going to stop here. If these numbers are not available here, that's mean we are not done our proof. We should keep going. Okay, but now it's easy to find a contradiction here. You will see it now. We found first equation, we found 2 to the 3m is a congruent to 1 mod 7. Now the second equation, we found 7 to the k. 7 to the k is a congruent to 1 mod 6. Okay, in the other word, I'm going to express this one as a solution. I'm going to replace here. We'll have 7 is multiplied by 7 to the k minus 1. So I have the first solution. I have this first solution. I have 6. I have this solution. We found 7 to the k minus 1 is a congruent 0 mod 6. Just taking number 1 to the left hand side of this equation is giving us this one. Okay, now I'm going to multiply both sides by 7. Okay, this one is a solution of the left hand side of this equation. Okay, with mod 6. I'm going to work on the right hand side of this equation. I will have 2 to the 3m minus 1 is a congruent to 0 mod 7. Okay, I'm going to multiply both sides by 6 is a solution of the right hand side of this equation. Let's put the purple star. Okay, we have the same equation. We get the solutions of these equations. The solution of the left hand side of this equation is written in terms of mod 6, but the right hand side of this equation as a solution is written in terms of mod 7, which is ridiculous. Okay, this is a big contradiction. That means we have no solutions, find no solutions for this equation when we have x and y strictly superior than 4. Okay, so the only solution that we found when we have x and y is inferior or equal to 4, we found x equals 1 and y equals 1. The second solution, we found x equals 2 and y equals 4. Okay, now we have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video.